Okay, so our project was to find the temperature of the thermistor. So way the thermistor works is it has a resistance variance depending on the temperature it is put in. As the temperature of this thing rises, the resistance across this thermistor decreases, and so we hooked up this one with a 5 kilo ohm resistor and 5 volt DC. So now as the resistance of this thing changes, the voltage drop across the thermistor should also change, and depending on those various temperatures we found the various voltages, and we have this one going into the our comparators. So our comparators are set to change give any signal out depending on the temperature that we want to represent on our LEDs, and we want our LEDs to represent each one as a range of 10 degrees. So the first one is showing us that the temperature is more than 0 degree, and the second one is showing that the temperature is more than 10 degrees. So as we go down the row, we have 10 LEDs, and the last one lights up at any temperature which is more than 90 degrees. So as we can see right now, it's at the room temperature, which according to our comparator is showing that it's more than 10 degrees, which is as we expect. So if I put my hand across the resistor, the value changes and the other LED lights up. So it's showing that the tip of my finger is at more than 20 degrees and less than 30 degrees. Okay, now let's see how we set these comparators up. So the way we read in the class is that if we have all these resistance with equal value, the value that each comparator compares has an even step. Like for example, if we have 10 resistance, so the first one should be at around 1, 2, 3, 4 and so on. Now we wanted our the resistance of the top one to be at around 4 volts, which we found using the thermistor resistance of the thermistor at 0 degree temperature, so between 0 and 10, and then finding the value depending on this one as how much voltage we want it to represent. So based on that one, because we wanted the 4 as our checkpoint, so we hooked up 2 kilo ohms resistor, and the net we found it to be around 10 kilo resistor. So first we hooked up this resistor, and after that we replaced all these resistors with a big black box. So it has a resistor, it was set to at around 8, and we varied the resistance of that one so that the voltage at this point should be the value should equal to the value that we want to compare it with. Changing that resistance did change the voltage at this point. So when we got that point, we hooked up with the first comparator, and we found the remaining voltage of that one. After that, we replaced the first resistance box with 2 resistance box, which in end should add up to the first one, but we changed the resistance of the first one. So we increased the resistance of the first one and decreased the resistance of the other ones, and found the point between those 2 resistance to match the second comparing value. When we got the second value, we hooked up to the second comparator and got the resistance of the remaining part, which is below that one. By repeating this process again and again, we found all the values that we wanted to compare with, and what was remaining, we connected that one to the last remaining part and connected that one into ground. We don't want to compare this one, but if we wanted, we can repeat this step again and again to find all the other values if we wanted to. In this case, we wanted only to connect 10 LEDs, so we found 10 resistance. So this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and after that whatever is here. So using that formula we can adjust these resistance. Even if this temperature is not precise enough, we can have a real thermometer which is very accurate and measure the voltage exactly to that point. And using the same resistance boxes we can precisely adjust these resistance so that we can have precise measurement of the LEDs on and off. See, in this time this is newly hot water, so let's check the temperature what we have. As we can see, 9 LEDs are lighting. That means the temperature should be more than 90 degrees in this case. If we check the temperature of this water which we heated up before but is not that hot, yeah, it's less than 40 degrees. Now as we can see, now the temperature is cooling down, is at around more than, now it's just more than 10 degrees, so that's pretty nice. Let's check the temperature of this cold water. Yeah, it's cold but not cold enough. The temperature is more than 10 degrees. Yes, yeah, it's more than 10 degrees. Now as we can see, when we take it out of the water, because of evaporation, the temperature of this tip goes down and it shows up only at more than 0 degrees. So it's between 0 and 10 degrees. When I touch it, its temperature starts to rise, and slowly 3 lights start to glow. That means the temperature is more than 30 degrees. And now it's back to the normal room temperature. So